Thank you. Well, you have a...
I liked it. Yes, thank you. So, do you want to have this?
Yes. No, because of the streaming. So you are listened by thousands of people.
Okay, thousands.
Yeah. There are lots of people watching the live stream.
Like an American predicator? Like an American predicator.
Yeah.
Let's do it. Okay, ladies and gentlemen, be ready for takeoff. Actually, we will speak about, yes, it works. We'll speak about something very well known, the Fibonacci sequence, and some implementation of the appearances of this sequence in various fields. Of course, with the purpose in mind that this can be implemented in various curricula at various ages and various, backgrounds for the children, the students, and so on. So what is the Fibonacci sequence? What is a golden ratio? I suppose that everybody here in this room knows what it is. Generally, it is related to ancient Greek. We will see that it's not totally true. The question is, what is harmonious proportion? It depends on who you are and what are your political goals in this world. You can have a look at the king's palaces in Paris, in Vienna, or the dictators' palaces in various places in this world. You will see some kind of buildings which are totally different. The basis is total symmetry, total square elements, but the Greeks thought, not always being big democrats, but they thought that the harmonious proportion should not be built on exactly symmetry, axial symmetry, and squares, and so on. And probably an harmonious proportion will be that if you have, for example, two segments whose lengths are A and B, the A plus B over A should be equal to A over B. That is to say that if you have such a rectangle with A at its length, at B at its width, you can cut out of that the maximal square, and the rectangle which is left respects exactly the same proportions. Actually, we will see that we can have two reverse directions in this building. One is top down, and one is down top. And so we can build rectangles, and we can also cut rectangles. But the name divine proportion has been quoted and had been tossed by this man. He was a monk in Italy, and he wrote a book, and there he wrote divine proportion, but without any specific intention, not like these journalists who called the Higgs boson the divine particle. And all these journalists who called the Big Bang, they wanted to say that this theory is ridiculous, but now this is a real name, the journalist. And so this golden section appears also in various proportions in the human body. This should be, actually, if you are looking at people who are supposed to be beautiful, you will see some kind of symmetry, but you will see that the ratio of this distance over this one is more or less the golden ratio. The ratio of the distance from here to here and from here to the floor should be close to, and I've been told that ladies are going on high heels in order to have a better approximation of this golden ratio. But now with all the top models who are almost anorexic, I suppose that some of these real proportions in the human body don't exist anymore. Not to be harmonious is really a problem. So tell them. So this is a kind of building with GeoGebra, and we could build this. This is a first square whose side is 1, a second square whose side is 1, then we have a square whose side is 2, and then the side is 3 and 5 and 13 and 8 and 13 and so on. And this proportion is also the proportion of the lengths of the diagonals of two consecutive rectangles. So this golden ratio is respected because if you are writing the successive elements of the Fibonacci sequence, the ratio of two successive elements tends to the golden ratio. It can be proven when you use another form of expressing the elements of the Fibonacci sequence, not as the sum of the two previous ones, but as a function of the integer n. It is 1 plus square root of 5 over 2 to the nth minus something else to the nth over. There is a local, let's say, formula for that. This kind of thinking appears, this kind of building or sharing the rectangles and so on, appears already in the Talmud for the sake of transforming a rectangular area into a square one, and at the time where irrational numbers were not existent. And so the sages of the Talmud began with the rectangle and cut out the maximal squares that they could, and so on. It's slightly different of the construction of these Fibonacci rectangles, but the way of thinking is exactly the way of thinking. The Talmud is full of mathematics because the sage needed a lot of probability theory, logic, and calculus, and so on before all these were existent. So they built the necessary mathematical tools for doing that. Once I will be happy to show how calculus was existent 2,000 years, or no, 1,500 years before Newton. This logo, for sure you know it. I have no shares in the company, but it is totally built on these Fibonacci rectangles. As teachers, you teach for sure the solution of a quadratic equation, and there is some kind of relation of upper bound on the solution of a quadratic equation. And when you are looking at this upper bound, actually we have some kind of equality when the coefficient here is the golden ratio, phi. If you want proofs, it can be done, but not now. In trigonometry, we can also have something, but it depends on which kind of trigonometry we want. If it's a trigonometry connected to geometry, we can have that. We will see that, but for more advanced students who know already what are trigonometric functions, you can do that, and you can compute. It's not very, very easy, let's say, because students, high school students, like at most fractions, but no complicated irrational expressions. But anyway, you can take the graph of the tangent function, of the cosine function, and in the first quadrant to have the point of intersection, and there you have the two tangents to the graphs. You have here a rectangle triangle, here is the right angle, and the proportion AB, AC over AB is the golden section. For ladies here, if you want to have a very nice golden earring, so in order for it to be nice, you will take a disc of a thin plate of gold, of course. If you want to add after that a diamond, you can, but it will change the center of mass. This is the only concern, and the price is not. But you take a disc of gold, and you cut out of this disc a smaller one, also circular, in that way, so you can hang your earring to your ear from here. And if you want the center of mass to be exactly here on the edge, the ratio of the radius of the big disk and the small disk has to be the golden ratio. So this is a double golden ring. Very interesting is that this has been discovered by somebody. The paper where I discovered that had a small error there. Maybe there was an earthquake, and Jerusalem was not exactly at the place where he situated it. But and Jerusalem is a very big city now with more than 700,000 inhabitants. So you can say that exactly one point is not the city. And which point has been chosen, I don't know, but the latitude of Jerusalem is 31.72 degrees, and the cotangent is a golden section. But if you are taking a rectangle, a golden rectangle, and looking at the diagonal divides the right angle at the corner into two angles. One of them is this one. And the other one, the complementary, is this one, which is a combination of the sun during the equinoxes in Jerusalem. Please come on the 21st of March and check it. So I must say that some old churches in Europe have been built on the basis of a golden rectangle, and the hypothesis of the author of this paper I found there, I forgot his name, sorry, is that it was because of the symbolic to be, even if you are in Europe, actually you feel in Jerusalem. So if you want to feel in Jerusalem, we will advertise that. The Catch Me conference will be in June 2020 in Jerusalem. So you can come and check all these angles. If you want to come and not check these angles, you can also. The Holy Temple on the Temple Mount in Jerusalem has a lot of proportions connected to the golden section. But one of the interesting things for mathematicians is that when we speak about the center of a triangle, actually there are at least 20 different centers in a triangle, orthocenter and center of mass and so on. So the name center is very, very flexible. And there is a say in the Talmud that Jerusalem is at the center of the land of Israel. How can you do that with a shape which is not a regular polygon? But actually, according to some descriptions of the borderlines of the land of Israel in the book of Numbers, at the end of the book, 29th chapter, the distance from the Holy Temple to the northern borderline and the distance from the Holy Temple to the southern borderline, the ratio is a golden ratio. We have that already. It's not my ark. Yes, I don't build ships, but there is a proportion between the length and the height of the ark. It's a golden ratio, at least a good approximation of it. Also, for the Ark of the Covenant, maybe you don't know that from the Bible, but you know that from Indiana Jones, who was looking for it. I can swear you, it is not at the place where the movie says. It's somewhere beneath the Temple Mount. The altar, the copper altar also, it's a square whose length outside is 5 cubits, and the height is 3 cubits, and the proportion is also a good approximation, at least good approximation for biblical purposes, because it's an approximation with 1 digit after the decimal point. But if you are measuring some lengths with your regular ruler, you don't need more than that. Okay, another shape very interesting is the pentagram. Actually, if you take a regular pentagon and draw the diagonals, you will have a 5 vertices star who is called the pentagram. And a lot of occurrences in the real world exist. And also a lot of trigonometry and various proportions related to the golden ratio, sometimes to the square of the golden ratio. And these proportions are exactly the proportions between the length units appearing in the Bible, a cubit and a palm and a foot and so on. But because they are connected to proportions in the human being, because this is a cubit, and this is a palm, a foot, you know what it is. And you know, please go and buy shoes, you will know what it is. Of course, it depends on the specific man or woman, but there is some kind of standardization for that, and we can have it in the human body. But I would like to, whoa. Okay, so we can do it in architecture with some castle from the Middle Age, with octagonal synagogues where we can have what we had here. This is a Middle Age castle and the 2 octagons, regular ones, and here we have halls who are trapezes, and the ratio of the large basis over the small one is a golden ratio. We have this in a synagogue in Budapest also. the same shape in Rumbach Street. And we could have this experiment done with GeoGebra, with some kind of augmented reality, and to check these proportions. It's totally trivial, it's not the same, but you can go to music. And now you will see the sounds, because in the Fibonacci rectangles you have built a kind of spiral, and this is a kind of spiral that you can have with a horn. And the proportions are also the proportions of a violin at various places, not only at one place, but at various places. And here, for the head of the violin, you have a spiral, which is also a Fibonacci spiral. You have that in piano, in octave. An octave has 13 notes, and divided out in 5 black and 8 white. All these are Fibonacci numbers, but what is important is that the frequencies of the notes, of the sounds, are related by Fibonacci proportions. Because an octave, the frequency is, within one octave, the frequency doubles. If you have a basic La, it's 44 hertz, 440 hertz. You go one octave up, you have 880. And all the proportions of the nice accords are in proportion with the related to Fibonacci proportions. You have that at composer with Bela, Bartok, and with Beethoven and Mozart and so on. You have that in the proportions of a recording studio design. When it is a golden rectangle, it has some reflection properties which make the studio very alive. But more than that, if you want the speaker wire, the cables inside the speaker wire for some manufacturers are dispatched according to the golden proportion. And also in the solar system you have that. Because the distance, if you are computing the distance, put the moon on top of the Earth and you are producing a golden triangle, center of the moon, center of the Earth, the edge of the Earth, and you have these kind of things. But much more than that, if you are looking at the average distance from the sun to every planet, the ratio of the distance from one planet to the inner planet, the average value of these ratios is the golden ratio. And the ancient, in the Chalcolithic period, they found a site in Varna, Bulgaria, with a lot of golden objects, and one of them is a rectangle with 2 holes in order to look at the skies and to compare distances. And this is a golden rectangle with these holes at very specific places. And we can do that also not only in space, but also in time, because space-time is really the normal structure for all of our life. Big Bang, we said. And the space-time, because we can compute time. Time is generally measured, computed according to astronomical phenomena. One of them is the sun. But the notion of a year for the sun is meaningful. A month is meaningless. It's totally arbitrary. The only thing is that February has to have 28 or 29 days, and but in order for the equinox to be as close to the 21st of March as possible. But besides that, useless months. The Muslim calendar is totally lunar. So the month is meaningful, the year meaningless. It's arbitrary, 12 months. So there is a difference of 11 days. So in order to have both features, you have to use a lunisolar calendar. The Hebrew calendar is lunisolar, and it has cycles based on what is called now the Meton's formula. Within 19 years, you have exactly 235 lunations. And you can divide that in 12 years of 12 months and 7 years of 13 months. And so you have a calibration of your calendar that respects both the seasons and the year. So you can calibrate your calendar, and what has to be in spring is in spring. The Passover festival is in spring, so it has to be respected. Our year, this year, is exactly lunisolar. So I have to stop. You will just have to have a look. Sara produced an activity for 5th grade students, building the calendar. It's possible to build the calendar with all the specifications, not only what I said. With these children, it has a lot of applications in class. We can do that by hand. We can do that with augmented reality using GeoGebra and other things. And much more exists connected to this golden section that what I said now, but there is some dictator here who stops me.